Discussed about controllers. Okay, if I leave uh, the auxiliary parts, this is how a controller looks. This is the feedback. Here we might have a sensor. This is the error. This is the input to the plant. This is the input, which is R of S. This is the output, C of S. So we have proportional controller, where U is proportional to E. U of S equals to Kp into E of S. This is the proportional constant. So I have already discussed about I'll see an example of discussed. This is the example of a first order lag, first order system, or first order lag, right? This is H of S. Q of I is entering. The area is A. So we have seen that Hs by Qs is equals to R H divided by ARS plus 1. Now we proportional controller for a first order lag. So the diagram looks something like this. Let me start with the pump. This is the motor. This is the filter. The reservoir of the tank. Shake valve. Here is the pressure relief valve. The dotted lines are known as pilot lines or pressure lines. From here it will be going to a valve, which is a 2x2 valve. It looks something like this. So if we push this, so the flow will start. So now this valve is connected to a sort of lever. Now this lever is connected, flow enters the tank. The lever is connected to a float which is there in this tank. So this is Qi. The movement of this is measured in X. The length of this arm is A, this arm is B. So what we do is that we just will keep this point fixed and we will keep this point fixed. Okay, and set this is hi. We can set a demand. So this is hd is the demand, right? This was initially set. Okay, and when this float rises, it will rise to a height of h, which is a function of t, and this will be something of this sort. Okay, so now we have h d sorry hi. This one, this is hi divided by hd, this is hd is equals to a by b from similar triangles. Also, now we have xf, this xf, this length xf divided by hi is equals to xf, this is xf divided by hi equals to b by a plus b. Also x backward, so this is xf, so sorry xb, so we can write xb by h, xb by h of is a by a plus b. Also we have xf minus xb is equals to x, and the flow through the valve is a valve coefficient into x, which is kv into xf minus xb, right? Also we know for a first order system, for tanks we have ht by qi is equals to rh. Let me make the block diagram. What enters is hd, the demand. It goes to a by b, what I get is hi now into b by a plus b, this is xf, minus xb, this x into kv gives me qi rh by arhs plus 1. This gives me h of t. Now h of t into a by a plus b will give me x of b, right? This is the circuit diagram. We have this as a by a plus b Now this can be written as kv a by a plus b so this is kp of the proportional controller, right? And the transfer function of this system now becomes kp rh 1 plus okay. Now if we divide the whole thing by rh, we have kp by a divided by s plus 1 by 1 plus kp by rh divided by arh. Now we can call this term alpha. So we have g of f equals to kp by a divided by s plus alpha. Now we can say that this is h t by h of d of t is equals to kp by a e to the power of minus alpha t. Alpha is also known as tau, which is the time constant. Okay, so okay, now we have, let's say, the input hd of t is equals to h0. So h is h0 by s, right? So we have h of s is equals to kp by a s plus alpha h0 by s. Now we can write this a into s plus alpha, separation of variables method. Let me write this alpha 1, this is alpha 2, because we already have a over here. So this will be we have alpha 1 plus for s alpha 1 plus alpha 2 is equals to 0. Alpha 2 into alpha, so we have written as a1 as a1 a2, I write it a1 a2 because we also have alpha. A2 into alpha equals to kp by a into h0. So a2 is equals to kp h0 by a alpha. A1 equals to minus kp h0 a alpha. Okay, now h of s becomes this is 1 minus 1 by s plus a is kp h0 a alpha 1 minus e to the power minus at h of t. So h at t tends to infinity is kp a alpha. Steady state error kp h0 by a alpha minus h0 is equals to h0 into 1 kp a alpha minus 1. We have alpha as this is alpha 1 plus kp rh arh. Okay, so steady state error equals to h0 kp, and it will go is 1 plus divided by so this is the steady state error. You can also write this as 1 by 1 plus kp is kva a plus b. Okay, this is the steady state error. Could have also found the steady state error like this. So this was kp, this was r by ars plus 1 for this kind of a system where k, this is another kp, not this one. Kp is limit h tends to 0 gs hs. This is for a first order system, and 1 by steady state 1 by 1 plus kp. So if we do check this and this, here this will go away. So kp will be, I'll call this kp dash. Kp dash will be kp into rh. So you can see this thing exactly matches.